In this video, we'll look at how to use binomial theorem. Before you watch this video, it might help to watch the videos on expanding, because one of those videos has the exact same questions. But that's the long way. Let's do it the fast way using binomial theorem. We'll start with x plus 2 to the power of 3. Before we get started though, we'll need to look at Pascal's triangle. Row 0 of Pascal's triangle is just a 1. Row 1 of Pascal's triangle is put a 1 and a 1 diagonally on each side of the original 1. Row 2 is put another 1 and a 1, but for this middle entry, add up the two diagonally above entries. 1 plus 1 is 2. For row 3, same thing, put a 1 and a 1, and now diagonally add 1 plus 2 gives 3. This spot is 2 plus 1 is 3. We can go on to row 4. You can go on forever, but we only need it up to row 3. So it starts with a 1 and a 1, and then add 1 plus 3, add 3 plus 3, add 3 plus 1. Why do we need Pascal's triangle? Because it turns out that the expansion of x plus 2 to the power of 3 has the coefficients given by Pascal's triangle. In other words, we can write a 1, a 3, and a 1. And let's put a plus sign in front of each of those because we're going to be adding on the terms. That's the first part. Second part is take the first part of your binomial, the x's. In this case, they start at 3 and they count down in each consecutive term. That is, it goes x to the power of 3, x to the power of 2, x to the power of 1, no x's. The second term, in this case a 2, starts off with an exponent 0 and counts up. It then becomes 2 to the power of 1, in the next term 2 to the power of 2, in the last term 2 to the power of 3. And now we can simplify that very quickly. What's 1 times 2 to the power of 0? That's 1 times 1. So we just get 1 times x3, which is x to the power of 3. For the second term, we have 3 times 2 to the power of 1. That's just 3 times 2, which is 6. So we get 6x squared. For the third term, we have 3 times 2 squared. What's 2 squared? 4. So it's 3 times 4, 12. So we get plus 12x. Don't need the 1 on the x. And for the last term, we just have 1 times x to the power of 0. That's 1 times 1. So what's 1 times 1 times 2 to the power of 3? 8. And very quickly, we've expanded that binomial by using Pascal's triangle and counting the exponents of the first part of the binomial down, and the exponents of the second part of the binomial count upwards. So let's do that again for 2x minus 1 all to the power of 3. Same row, row 3, because we have an exponent 3. That's why we pick row 3 of Pascal's triangle. We write down the coefficients and put pluses in front of them because we're adding each term. Now start with your first thing, the 2 to the power of x. It starts with an exponent 3, and on each consecutive term counts down. Make sure to put all of 2 to the power of x in brackets, because the whole thing, 2 to the power of x, gets the exponent 3, then 2, then 1, then 0. The second part of your binomial is negative 1. Let's start it to the power of 0. On the next term, it's to the power of 1. On the next term, it's to the power of 2. And on the last term, it's to the power of 3. It looks complicated, but it's way faster than trying to expand this or FOIL this. Because look what happens. You hear it again. You get 1 times negative 1 to the power of 0. That's just 1. And so you get 1 times 2 to the power of 3, which is 8, and x to the power of 3, which is x cubed. For this one, though, I want to be a little bit careful because it's 3 times negative 1 to the power of 1, which is just negative 1. So we get 3 times negative 1 is negative 3. And then here we get 2 squared. So maybe we should show some work here. Let's simplify a bit. We'll leave this as 3. And we'll leave this as times negative 1. And then for inside the brackets there, you could use a calculator if you wanted, or just think of this as 2 squared, 4. And x squared, x squared. We'll come back to that. You can do that all in one step if you're able to handle it without making mistakes. For the next term, it's going to be 3 times 2 to the power of 1 and x to the power of 1, so that just becomes 2x. And then this negative 1 squared, what's a negative times a negative? A positive, so negative 1 squared is just 1. On this last term, we could probably do this one all at once, because it's 1 times 2x to the power of 0. Anything to the power of 0 is 1, so we get 1 times negative 1 to the power of 3. That's negative times a negative is a positive, times a negative again is a negative. So let's finish our last step of simplifying. Nothing to do with 8x to the power of 3, but for this one we have 3 times negative 1, which is negative 3, times 4 is negative 12, x squared. And for this one we have 3 times 2x, which is 6x, times 1 is just 6x. And then plus negative 1 is just subtract 1. And so what did we do there? For both questions, we used binomial theorem. That is, we wrote the coefficients of Pascal's triangle corresponding to the row number of the exponent. And then we counted the first terms. Let's look at this row. The first term's exponent counts down each time. And the second term's exponent in both questions counts upwards. And that's how to do binomial theorem.